Start things up now. Thank you all for coming. I appreciate everybody showing up. Some people are still rolling in. This is the next of our webinar series, and this one's going to be about breaking analysis. Breaking analysis used with GPS-based data in math channels. So it's we're trying to give some a little bit more detailed analysis type of thing, but also using mostly GPS channels. I think our co-host Jeremy Lucas is going to show us a little bit of brake pressure a couple of times. So,
and then, but the funny part was on my way home, I go through those rotaries.
Matt, mute your microphone if you could. The the first thing I'd like to do though, as we go, is do some introductions around the room. We've got our a normal crew of AIM support folks that are going to be here and helping in your questions and answers. The way this should work for you is if you have a question that you want answered during the presentation, type it into the questions and answers box. If you want to have some quick conversation with either the group that are answering questions or with other folks that are attending the webinar, put it into the chat box. And then once you get it into the questions and answer box, the guys will answer it directly, and you'll be able to see it there. And when we're done, we'll also have a document that within 2 or 3 days we'll take those questions and answers, put them into a PDF document, and put it out onto the YouTube in the description box, a link to it, so everybody can see what the questions are later as well. So, but we'll try to answer them live, the ones that really pertain to the braking analysis with GPS-based data. So I appreciate that. If you'd follow along with that, that makes it easier for Jeremy and I to answer the questions on the fly. So let's do some quick introductions of who's going to be answering the questions behind the scenes. Some of our best AIM techs is who we got running along with us here. Let's start with Robbie.
Hey guys, good to see you all again. I've been really interested in these last couple of topics. They've been really kind of peeling that onion back, so I can't wait to see what's in store for us today. And of course, questions and answers, just get them into that questions and answers section so we can either address them live or as we see fit. So
perfect. Thank you, Robbie. Cameron over in Roanoke, tell us a little bit about yourself and what you're going to do today.
Hello, everyone. Cameron, like Roger said, from the Roanoke, Virginia office. Yeah, today we'll be doing the same thing. Any questions, we will be answering them in the Q&A. And, we're excited to be here, excited to get into some braking analysis. So if you have any questions, just put them in that box and we'll get to you. Perfect.
Thank you very much. Brick, a little bit about you.
Hey guys, I'm Brick. I'm also out of the Roanoke, Virginia office, and just like the other guys, I'm one of the technicians here, and I'll be answering some of the questions in the question and answers. Feel free to ask away.
Thank you, Brick, very much. Robinson.
Hey guys, I'm just here to back up these big guns like Roger. If you have any further questions, we'll be the ones in the Q&A. Happy to help.
Perfect. Robinson's microphone's not working great, so he'll be his keyboard works fine, so he'll be typing stuff in. So perfect. And we also again have Emiliano from our Milan office. Emiliano is up late at night over in Italy, but we are very thankful that he's here to help us. Tell us a little bit about yourself, Emiliano.
Here, Emiliano from Italy. I mainly develop software for the company. I work for AIM since 20 years. I'm here to help, and I'm thankful to all of you to having me here.
We are very, very thankful that you are here. I appreciate all that you do for us. Appreciate that. And Emiliano will be answering questions in the questions and answers as well. So perfect. Let me click ahead one here. Our co-host today is Jeremy Lucas. This is his second video he's worked with us on, this second webinar. Jeremy, tell us a little bit about yourself, and then we'll begin the process of talking about braking with GPS data.
Well, my name is Jeremy Lucas, and I'm a club racer. I've been racing for about 20 years. So I'm at a lot of the Midwest tracks, as far up as up into Michigan, down to Road Atlanta, and anywhere in between. I've raced with both SCCA and NASA over the years. Right now, I primarily race with NASA, but I've been doing data acquisition for 14 years. I got into it, as a way to improve my own driving and realized that other people needed help as well. And being an engineer, just something that kind of came naturally for me. So it was very easy for me to help relate my knowledge to other people and help get them to be faster as well. And thanks for having me here for the webinar.
Absolutely. Thanks again for doing this the second time. I know it's a lot of work for our co-host to come in and get prepared, and we appreciate it a lot. So let's go ahead and share race. Nope, we're going to go to the next slide in here. Actually, now that I think about it, so Jeremy has put together a pretty good idea. What we're gonna give you some slides, and we're going to talk about some detail. Jeremy is, and then when we're done with that, then we're going to jump into some live data. So I'm going to remote control and give Jeremy the mouse. You click once, Jeremy, and you are off and running. Let's hope. And again, we'll watch the questions. If anybody has questions about this specific topics or something that Jeremy shows, make sure you put it into the questions and answers. So have fun, Jeremy.
Okay. I first want to apologize from the fact I'm an engineer. Sometimes I make assumptions that maybe aren't obvious because it's just I don't think about it, but maybe it's something you need more detail on. So if I jump over something or miss some detail that you want, just go ahead and pop that question in, and we'll try and get that answered. Make sure we fill in all the blanks. Something else we've done here as feedback from the last session last week on these math channel pages is to go ahead and add in the screenshot from the math channels window in analysis. Not only does that help you see where the formula goes into the math channels from where we're viewing it here on the screen, but also shows you what I'm doing for scaling in units and that kind of thing. So our first math channel that we're going to talk about here is GPS GSUM. And if you're looking at a textbook or some type of data analysis textbook, or squiggly lines or that kind of thing, this is the formula that you're going to see shown in the book, where GSUM is the square root of the sum of the squares of lateral G and longitudinal G. And just like always, when I make slides to show things as this, I always color code my formulas. So something that's green is a math formula that you're calculating. Something that is blue is a measured value that is coming into the logger. And something that is red is a constant. Today, we don't have any constants, so that's why you don't see any red, but I'm just reiterating kind of my standard operating procedure for showing formulas. So your GSUM will look something like this when you're done. You can scale it how you like. I usually use 0 to 2 for my scaling. So this is what the math formula looks like in AIM speak, and this is where you put it into your math channels box.
Jeremy, in the recent past, we before you leave that screen, maybe Robbie can plug in the YouTube video. We did a video just on GSUM and how to create it and show where to plug all these things in as well. So Robbie will plug in the link for you guys in the chat box so you can save that for later.
The next math formula that we're going to look at is GPS inverse long G. So the reason why we're doing this is simply for display purposes. It doesn't change the value. Inverse just means the opposite. So it's just going to flip the sign on it so that when we're breaking, the long G line goes up on the scale instead of down. And when we show you some examples here in a little bit, you'll see why we want to do that. But again, this is what the formula looks like from a textbook standpoint, and this is what it looks like when you input it into AIM and put it in the formula box here. And when you're putting your formulas in, you can always hit this test channel box to make sure that AIM recognizes the way you've put it in and it doesn't see any formatting problems. It's a good thing to do when you're adding new formulas. Another channel we're going to talk about is GPS brake speed. You may also hear this called braking aggressiveness. It is a derivative formula that takes the derivative of long G over time. So brake speed is what we're going to end up calculating, and it's going to use the long G and time in order to achieve that. You may see it represented in a formula style or kind of written out in words. And when we look at the formula here, this part of the formula is just this portion here, this derive GPS long Excel. That's what this portion is. But we've gone in here and we've added some filtering to it so that we're only calculating that value when the long G is less than minus 0.15. And the reason why I'm doing that is because I only want it to happen when it's in a braking event. And from looking at data at your car, you may tune this number to be a little bit less. Maybe it's minus 0.1 or something, but you want to just look at where you've lifted off on the gas, but you haven't hit the brake yet. What is that natural decel drag number that you see from your car, right? It's not going to be zero because you're not in a frictionless environment. The friction of the tires and friction of everything is going to have some natural decel, and you want to make sure that you set the threshold to be after that amount.
Perfect. So one of the things that the questions I get sometimes is some of the channels that we can use for that, and we're going to show GPS-based channels today. Obviously, the one of the things that I do like to put in here is a poll for folks that have different pieces of equipment. Certainly, most everybody's going to have that GPS piece. I'm gonna launch a poll here, and it's going to be a multiple choice poll. And if you could let us know what pieces of equipment that you actually are using, it's kind of interesting. Sometimes it helps us a ton with creating content and starting to plan for the future webinars that we're doing. So if you could select any of the different pieces of hardware, AIM hardware that you use, that would be great in this poll. The numbers are climbing pretty quickly. We'll leave it up for maybe another 20 or 30 seconds. And if you, once you have done that, if you submit to the bottom of the box, click the submit button, that box will go away. I appreciate everybody doing that. We're gonna end the polling here in just a couple of seconds, and then jump back to Jeremy. And there we go. Let's close that down, and then we'll do 2 or 3 more polls the rest of the day. And again, it's kind of interesting to do it. We'll share some of those with you, and it helps us really as we plan for the future webinars. So I appreciate that. Go ahead, Jeremy, to your next slide.
Okay. So we've covered the formulas that I wanted to use today. Now I want to show you some examples of using those formulas on some PowerPoint slides here. So here we're looking at GPS inverse long G versus brake pressure. And we're not going to use brake pressure throughout the rest of the discussion, but I want you to understand the relationship of what you see in that inverse long G versus what you would see if you had a brake pressure channel. Here we have 2 examples. One driver here is on Hoosiers, another driver over here is on Toyo RRs. Different braking speed initiation points, but you can see how the driver here with the brake pressure is doing a much better job of modulating off of the brake pressure as he gets into the corner.
Make sure you click once, Jeremy. We can't see your cursor yet. There you go. Thank you.
There we go.
Okay.
So you can see the modulation down here with the slowly decreasing brake pressure. Now over here on driver B, big initial spike, off, on, off, on, off, on, off, on, and you see the resultant trace that you get from that inverse long G. So even though we may have a car that doesn't have a brake pressure sensor, you can see how that the long G is going to show some of that detail as to what's going on with the driver's foot on the brake pedal. Very important for you if you have a GPS only system like a Solo. Okay, next I want to start to begin to build that relationship for you of explaining what GPS GSUM is. So here we have GPS GSUM, lateral acceleration, and inverse long G all shown together. Your standard lat long are up here at the top, and your GSUM is down here at the bottom. If you notice the shape of the curve seems very similar. However, where they differ is in this area of combination where they're both applied at the same time. So here it just happens to be that the cursor, we're at 0.5 for both of these, but if you look at what the value is on the GSUM, you can see it's 0.7. That's because of that mathematical combination formula that's occurring when we have both values. So if I were to click here, the value would be identical, but here it's not as low because we're combining this portion of the lateral G into the long G to get this total sum number. We can look at that in a little bit different ways as well. I'll show you some more examples here in a second. So on Tuesday, Matt talked about friction circles. And I want to start to build that relationship too between what he talked about with friction circle and what we're talking about today with GSUM. So on the left, you see GSUM for an entire lap. On the right, you see friction circle for an entire lap. Looking at friction circle for an entire lap gives you a good idea if the driver is using the full performance envelope of the car. However, looking at GPS GSUM for a full lap, not really that useful. You're not really understanding if the driver is using all of the friction circle. All you can really tell is about kind of if the maxes are kind of lining up, which is probably usually going to be this peak turning point, because that's where most people are comfortable getting to their full use of the tire. But if we take a slice of this and just look at just one corner here and zoom into just that area, this is what it looks like. Now, through the magic of PowerPoint here, I have kept a under-intensified image of the entire friction circle. You can't see this in your AIM software. This is just for the purposes of discussion here so that you help to make the relationship between what we were looking at before and what we're looking at now. So we've zoomed in on this one corner, which ends up being represented by just this one line in the friction circle. So we have our lateral acceleration, we have our inverse long G, and we have our GSUM, right? Those are the intersection points, and this is where that is on the friction circle. We're just tying those things together so that you understand the relationship of what you see on the measures graph versus what you would see if you're looking at a friction circle. But to even more bring that concept home, I'm going to show it to you this way. Now, hopefully at some point in your prior education, you've seen this formula before here for the formula for a right angle triangle, maybe algebra class or something like that, where a squared plus b squared equals c squared. That's the same thing we're talking about here. This is the same formula that we're using for GSUM. The GPS lateral is at 0.27, the long G is at 0.73, and the GSUM is at 0.78. So we go from the origin on the friction circle over 0.27, we go down the longitudinal 0.73, and this diagonal arm is that GSUM. So when you think about GSUM, I want you to think about that point being out on this curve because it's the diagonal back to the origin or the hypotenuse of the triangle, because we have a right angle triangle here. We go over and down, or we can just go on the diagonal. Does that make sense for everybody?
Yeah, because your tires don't care that it's two different components, right? It's feeling that
right.
one large component. Exactly.
Yep. So now let's look at putting some of that together with some analysis of a specific driver. The blue line here is our GSUM, and the orange line is our inverse long G. And now I'm just showing half of a friction circle because we're only looking at a single turn. So if I were to show the whole thing, it'd just be white space, right? So just to make it bigger in PowerPoint here, I've zoomed in here. And then also with the magic of PowerPoint, I'm able to throw in a line here, kind of showing what maybe the actual traction threshold limit is for this driver tire combination, right? This is the keyhole at Mid-Ohio. When we see a dip like this, and we see the corresponding dip also on the friction circle where it's not out at the edge, typically that means the driver could have braked later going into that corner. There's some pause or transition area where the driver has started to come off the brakes but isn't yet turning. So a lot of time that means you could have gone in there a little deeper. But one of the reasons why I threw this example in there is because you can't always just assume by looking at these two graphs and only looking at the lines that you know the whole story. Notice that the peak braking friction here is only minus 0.8 G. There's no R compound tires where that is the proper limit, right? In this case, this was actually on a wet track. So saying the driver could have trail braked in, maybe that's not so applicable for the wet track situation, right? So you need to make sure that you're considering the whole picture, not just making a bunch of assumptions by looking at one graph. It's kind of a little bit of a trick question, right? But I wanted to make sure and point out that when you see something that's not the way you expect it, to make sure you expand what you're thinking about as to why that may be.
Trail braking in the rain at Mid-Ohio, that might be a one-time kind of a thing.
Yeah. Let's look. This is the same driver in the same corner in the dry. Notice how the diagram is much different, right? There's a much less of a drop off from peak braking Gs to when churning is start to be fed in. And you can see that same story replicated here in the friction circle. And also notice that the peak is higher. It's not 0.8, it's now -1. Is this a perfect friction circle? No, but it's certainly better than the other one. but it shows you the areas at which some improvement can still be made. There's still some room for improvement here on transitioning from full brake to turning. This is a different driver, same corner. Notice here that the peak doesn't come till much later, right? And you see that here in the friction circle. The driver has started turning before he gets to that point where he's at the peak braking point. There's some funny stuff going on here as well, some looping. Maybe the driver was turning and braking too much and got into a little oversteer. There's more analysis that can be done to figure out what's going on with this loop. Not the point of today's conversation. But again, he did a good job of getting to the limit of friction, but maybe not necessarily at the right point in the event. That point should have been sooner with a smoother transition and making sure to try and use this area here under the curve that we're missing by not using all of the available friction that the tire can give. All right. So yeah, that inverse GPS long is the same as long G, except we flipped the sign so that it goes up instead of down.
Same exact information, just that he mentioned it earlier in the video. Later on, maybe go back and watch it again. It's just he's manipulated a little bit to make it work.
And the reason why is I want to see it line up completely with this curve here, right? I want to know the point at which I got off the brakes and steering started. If I don't flip it, it's not as easy to make that relationship here and see the point at which turning started and braking started coming off. It's just to get them to line up. So that's also important that they're at the same scale, because if they're not the same scale, you won't see this same kind of image.
Yeah, a great visual way of working it. Let's take a minute for another poll and give everybody a little bit of a break to get involved as well. We're talking about road racing here at Mid-Ohio, but we have lots of people with many other types of race cars, race vehicles, different forms of motorsports. I'm going to launch a poll here and take a look at the what type of motorsports do you do? Again, we have been watching and we have been learning from you, and we've been chatting with different more different co-hosts that come from different forms of motorsports. So based on what you guys have been sharing with us, we're going to be adjusting what we do. So I appreciate those of you doing this, and it is multiple choice, so you can pick a couple different ones if you do different forms of motorsports. I appreciate that. So we're already up about 75% of you have already voted. So we're going to end this poll here in just a couple more seconds. If you haven't got there yet, go ahead and do that, and then we'll get back to Jeremy putting the pieces together in the in the friction circle. So let me end that poll, and then I want to share it. Let everybody kind of give you a good idea of what everybody is doing here. So there's your screen on there. Auto racing, which is basically road racing in cars, is still a majority of you, but karting and motorcycles still a pretty good chunk. Those of you that wrote other down at the we have 6% that were other. If you have a chance over in the chat box, if you would type in what your other is, that would be of interest to us. So if over in the chat box, just type in there what other form of motorsports you might be doing. So I'm going to get the share box out of the way, and then let Jeremy grab the mouse and click, and then we're back up and running. Thank you, Jeremy.
Okay. While we were doing that poll, a question came in asking about why aren't we just using the absolute of long G? Because the reason we're doing that is because we're focusing on just the braking portion. Whereas if I had done the absolute, the positive accelerations would also show up on this. Because of the way I'm scaling, I want the positive accelerations, which would be accelerating with the gas pedal, to be below what we see on the graph. That way we're just focusing on just the braking portion of the long G.
Good clarity there.
Okay. Another driver, same corner, but on Hoosiers this time. So I've kept the same profile at that -1G that we saw with the Toyo tires on the previous example. But now here you can clearly see the additional grip available from the Hoosier compound, and it's basically making that envelope in the friction circle bigger. But the driver is only making use of that in braking and in full turning, and not making use of it in the transition area. So there's a lot of work to be done. See how big this dip is? where the driver is braking too early and then also not turning in while using enough of the tire. It's a very separated events. This is almost like a D person where they've done their braking, they've got off the brakes completely, and they've started to turn in. Their turning in point, they've already released about half the brake pressure. So ideally, we want to see this curve move up and be a little bit more of a horizontal or a little bit of an upslope. As you come off the pedal, you're feeding in the turn. And if you're not at the right point, obviously you can't do that. You can't automatically turn in for a corner at the point where you're lifting off the brake pedal. That's what tells you you could have gone a little bit deeper on the brakes, right? And you have to do that in steps. You can't just say, oh, I'm going to do it 100 feet later next time. Well, that may be too far, right? You have to kind of incrementally work towards that point where you're getting comfortable with braking later, getting that point where you're lifting off the brakes as you're starting to turn in. But it's important to note that you will see differences in terms of the potential of the car based on the kind of tires and the setup and all that kind of stuff. The last formula that I gave you guys was GPS brake speed or brake aggression. And I just wanted to show you an example of what that looks like relative to the longitudinal acceleration. Two different drivers, same type of tire, right? But you can see that the braking aggression is much different. And that braking aggression here is basically just another way to represent the slope of this line, because the math formula is taking the derivative, which is telling you the rate of change, right? So a higher peak means a much faster rate of change, which means the application of the pedal was much quicker, right? We don't care about what this number is. I just left the units on here to show you. It's just numbers. It doesn't have it's not like a G or a feet per second or anything like that. It's just a comparative number. And you want to use the brake speed comparison either between the same driver on different laps or drivers in similar equipment during the same time of day, because the peaks of these numbers are going to change based on the tires, the track condition, all those kinds of things. So it's not an absolute number. You can't say, oh, you need to hit -3 on your brake aggression. That's not a statement you can make, right? It's a comparative number, and it helps flag some of these differences that you want to pay attention to when you're looking at comparison between laps or comparison between drivers under similar conditions.
Sometimes if the track is going uphill, the brake aggression number may be very large because you can get after it hard, or if you're going downhill,
exactly,
your brake
yes.
aggression may be lower. So it is a great comparative thing, but compared to the same corner.
Yeah, that's a good point. You can't necessarily get the same number in every corner as well. And I also tend to focus on the brake speed, and we'll also talk about coming up here, the amount of time it takes to get to the brakes. More importantly, becomes more important the faster the corner going into the corner is. So yeah, I mentioned that time to full brake, right? This is another key point. It's related to that braking aggression in terms of how quickly you're getting on the pedal. But with the software, we can actually measure how long it takes to go from that time when you first touch the brake pedal to when you've built full braking G. Notice I didn't say full braking stroke, right? Because full braking G is also a function of the pads that you use, right? Some pads, when you get on the pedal, they've got to build just a little bit of heat before they make that peak friction and give you that peak braking G, right? So what we're concerned about here is that total concept of the combination of what you have for equipment and what you're doing with the pedal in the car. So here's how you would measure that on a sample set of data here. We've got G-sum overlaid with the inverse long G, because that's how I typically pair those two together. To use the delta function, you go up to this red triangle here. You click that first. Then your next point is going to be your anchor point. That's your second click. It's very important to get this click here where you want it, because you can't change it without going back out of the function. Then your next click is your measure point. That you can continue to refine and move around a little bit if you don't get it right the first try. But that anchor point with that second click, you want to make sure that's as close as you can get it to where you want to be. Then once you have that shown, you'll get this little value up here in this parentheses. So in this particular example, the driver took 1.1 seconds to apply the pedal to the point at which he was able to get peak braking friction, right? The decel rate was at its highest. And most of that is just the driver, and some smaller portion of that is the brake compound, like I mentioned. So we'll use that in some of the live examples as well, so you can see it on some other data. But yeah, those steps are very key. And then when you're done looking at the delta, you go back and click the red box one more time to turn the delta function off. All right, now we're going to go over to the actual live data and cover some examples that way.
And while we're doing that, let me add in another poll just for fun while we're doing that. The experience level of everybody that everybody is watching here. I'm launching a poll that, and the question is, how much experience do you have during, using data acquisition hardware and software, not just AIM, but just your overall experience level. And you can answer that. You can only select one, but we really appreciate this as well. It's been helpful in understanding how we begin to build, the upcoming courses, and we want to try to make sure you try to please as many people as we can, and I'll share these numbers with you here in just a moment when everybody gets done voting. But we want to throw out some things, and in some of Jeremy's topics today, there's some a little bit more advanced topics in there, and then and the one that we're going to do next week is maybe a step back just a little bit. So we're trying to hit as many people as we can, and even when we show the more advanced ones like Jeremy's or some that are maybe more for the beginner folks, we always are throwing in something that's either advanced on the basic one, so we keep the interest of everybody, or something that everybody can understand and work with. So I'm going to end the polling there. Pretty good numbers of folks have voted, and it looks like it's slowed down a bunch, a little over a minute we've had it going. I'm going to end that polling, and let's share the results, and let everybody take a look at who's of the group is what's out there. Our biggest group, 1 to 2 years, that's been pretty standard. And then the second biggest group has been that 5 to 10 year area. So we've got some people that have learned enough to really begin to heavily use it. The 1 and 2 years, of course, the 5 and 10 year guys, they've been using it quite a bit, all forms of data. But boy, you start stacking up the new users and the 1 month to 6 months and the 6 months to a year. We still are pretty biased towards fairly new users of the stuff. So, and you're seeing that in some of the topics that we're seeing. So I'm going to stop the sharing or pull that back, and then I'm going to do a new share and share the Ray Studio software. And you've got the mouse now, Jeremy. Make sure you click once so you can go. Oh, very good. And we'll look at some of the stuff that he's just talked about, but show it to you in some real live data.
Okay, as you can see from the track map here, we are looking at Gingerman Raceway in Michigan. We're looking at 2 different drivers. These happen to both be Spec E30 cars on Spec Toyo tires. And we're going to be comparing, the drivers are about 3 seconds different in lap time. Looking at the friction circle and the G-sum long G trace of the first driver. Here's in green is the first driver, driver A, doing a somewhat good job of getting out to the outer profiles of the friction circle. Here's driver B, a little bit more crisscrossing going on, not quite as much meat filling out the sides of the friction circle. And when we overlay them, you can see that getting a little bit more peak braking with driver A, and also especially turning in one direction, a little bit more comfortable using more of the car. You will also sometimes see that kind of disparity left to right in the friction circle, where maybe somebody is more comfortable turning one way than the other because they do that more often, right? Typically you see more data on this side just because of it being right-hand turns, and it can be, just kind of a function of what the driver is more comfortable with. I should point out that this is also an example, just like on Matt's on Tuesday, of using multiple views. Roger has gone ahead and made a video available, and I think Robbie's going to put the link in the chat here. So if you guys aren't used to using the multiple view option, you can go and watch that video. But what it allows us to do is have our measures graph, which is normally the boss, be uncoupled from the other plots. So for example, notice I'm turning speed on and off, but it's not changing anything in my friction circle. Typically, when we look at friction circle, we only want the long G here to be available. There are other uses of XY plots other than friction circle, where we may want other values, but when we're using as friction circle, we just want to see that. So we want them to be decoupled, and using the multiple views is what allows us to do that. All right, I'm going to go and look at, let's zoom in here on turn 1 here and start to look at a little bit more detail between the two. When you do have these multiple windows going on, you got to make sure that, so here we're looking at driver A, but here it's on test compare. So make sure that we're going over to driver A. And then also if you end up selecting anything down here in the lap view down here, you want to make sure that you're on the same set of data, because these are now decoupled because you have multiple sessions open. They're not necessarily showing you all the same thing. So here we're looking at just driver A. I'm going to zoom in just a little bit more here on this graph. So this is what the curve looks like. Not a very pretty looking graph on the friction circle. And we can see there's a bit of modulation going on, and there's a pretty big dip here, right? So the driver is getting on the brakes and then isn't ready to turn in yet, right? Could have broke later, right? That's the number one thing of seeing this dip, where G sum and long G both dip together before they separate, right? That's kind of the key characteristic we're looking here, where they both dip together before they separate. That means the braking pressure was coming off before you're starting to turn the wheel and turn into the corner. Hopefully that makes sense to you guys. Same type of view that you have here. This isn't a, somebody was asking about, well, why would you look at one or the other? It's not really that there's a one correct answer, right? Like I said, looking at friction circle is a lot more useful when you're looking at an entire lap than looking at G-sum. G-sum over looking at an entire lap is almost no meaning. But also then when you zoom in, maybe it's a function of how much screen real estate you have, and you don't want to have measures graph and friction circle up at the same time. You can see some of the same type of information depending on which way you look at it. And you may be more comfortable looking at it one way versus the other. So it's not that this is correct and this is wrong. It's just different ways to look at the same data, and maybe one is more appealing to you than the other. As I get more comfortable, or as you get more comfortable, right, just like the process I went through years ago, you'll find yourself looking maybe more at one type of data, right? Normally I want to have my measures graph maximized as much as possible, so I can see that level of detail, right? Maybe I don't want friction circle taking up a bunch of my screen, right? That's just a different way to look at the same type of information, less zooming in and out. There's not a right or a wrong there. But let's take a look at this between the two drivers, right? So we see the shape for driver A here, same area of data for driver B. Wow, right away you can see, if you'll overlay them, right? The peak is less, the time of transition is increased, the brake speed or brake aggression is less, right? We want to see the friction circle for both. Make sure we just turn that on as well. You can see the driver B friction circle is a smoother line, but it's smoother not necessarily in a good way. The driver's not using all of the available friction of the tire. The other thing I wanted to point out here is when you look at these curves here between driver A, you see a fair amount of detail in the G-sum and inverse G. When we look at the driver B, notice how much more smoother the curves are. Part of this difference is because driver B is solo 1 data and driver A is solo 2 data. So with the newer hardware, you're able to get a little bit more detail out of the information. You know, I used to think that there wasn't a lot of difference just conceptually between a solo 1 and a solo 2, but as you get into more analysis, you find that there is this extra level of detail that you will get out of having a solo 2, even if you're not using, you know, some of the other features like Wi-Fi and those kinds of things. So that's another important thing to understand when you're looking at data, is you may have different types of logging equipment that will give you a slightly different representation of what we're looking at.
Yeah, the hardware just continues to improve, right?
It does, yeah.
There's a kind of a cool question here that kind of fits in where you're at, but
Sure.
Should the slope of aggression always be the same per corner and equipment being the same, but with a different end value? The the depth of it. You know, there are things that change that, right? The speed, you mentioned once already, that was the speed entering a course. Sometimes a high speed one, maybe you don't want as much, and maybe you're a left foot braker or a right foot braker. There's some different things that may tweak that. What do you think about that, Jeremy?
You know, I don't know that I've done a detailed comparison on that. I mean, obviously, brake aggression is related to that slope, because slope is the rate of change, is what we're getting out of the derivative. So there is a the steepness of the braking curve is going to be related to that braking aggression number. But I've not done a comparison to see exactly if you end up with a different peak or not. I would think you would end up with about the same type of number if the slope is the same, because again, if your beginning and ending points are the same for the slope, you're going to get a similar aggression number. But it's not going to always be that number every time you go to that corner, because remember, there's other things that affect the friction that's available at the tire, whether it's the weather, the condition of the tire, the temperature. All of those things are going to play a part. So it's not, oh, I'm going to hit -3 every time I go into turn 1. That's not the case. That's why we said when we're looking at brake speed or brake aggression, it's a comparative number under similar circumstances, whether that's in a given session or between driver A driving and driver B driving the same session, that kind of thing.
Perfect. Yep. Okay.
So yes, someone was asking, aren't both of these drivers braking a little early? That is completely the case. For those of you that have been to Gingerman, the brake zone kind of ends over a crest. So it's a very easy tendency to want to start to brake a little too early. And that's something that you just kind of have to work on and try to overcome as you're building up speed throughout your weekend, is to try and get comfortable moving that braking point back farther.
Always interesting. James used that term early a couple weeks ago, unpeeling the onion. We would see these curves being such as they are, and you always would ask yourself why, right? So then you start to dig in and understand, and then at Gingerman, with it going over the brow of a hill, there's a good reason why this happens. So always fun to dig in and find the multiple layers of information.
If you start to be too aggressive on a corner, you'll find you get funny shapes in your friction circle plot, like where you start getting those loops and things where you've exceeded the friction and now you're recovering the car in the middle of the turn.
Yeah, chasing it.
Yeah, you're kind of maybe you're chasing the tail, or maybe you have a push or something. But you can also see some of that if you have a steering angle sensor, where you can see that your lateral G, as you're starting to turn in, you're increasing turning the wheel, but your lateral G isn't increasing because you've exceeded the available friction available at grip at the tire, and turning the wheel is just causing more push. That's a really good use of having a steering angle sensor, and one of the things you certainly want to look at if you have that available to you. Not as easy to see with just the GPS only data,
because we're seeing only the end result, right? With this just GPS based data like we are showing
right
here.
So let me go in, and a couple other things I want to remind you about when you're looking at the corner here. So here we're on lap 4, right? Remember, you can click and drag here and quickly go from lap to lap, getting the same behavior, right? You can see I don't always have that dip going into the corner. Some of these are smoother.
Less, yeah, there's a good
right
one there. Yep.
So it's a good way to quickly scan and see how consistent your behavior is in a corner, to just click and drag between the different windows, between the different laps.
The functions we're looking at stay zoomed in, and yet you're looking at different laps. That's very, very, very handy tool.
Yeah, that's the #1 reason to use these down here for me personally, is to be able to quickly make that comparison between laps. Let me go ahead and do a live demo of that delta function we talked about. So here's that delta button up here in your window, up with all your icons. See, delta on off pops up as the mouse over text. When you go ahead and click that, the next point you click, you want to make sure that you're near the base of your long G, but you can't be too close to the axis or it turns into a hand because it wants to drag the divider line. So you come up just a little bit from where you want to be and place that anchor point. Now we've got that anchor point at the base of the buildup of the inverse long G. Next, we're going to go over to the peak point. This is where if you don't get it quite right, you can click again and kind of move it a little bit more precisely, but it's going to keep that anchor point. Now, if I don't click again, we can then go and look here at this number and see that the time from braking initiation to peak braking G is 0.6 seconds. So we're getting kind of close to that 0.5 G target, but not quite there yet. Let's take a look at the other driver. I unclick the red box to turn that back off, come back to the other driver here, turn it back on. I want to get down here to this peak braking point. It's kind of a little bit of a soft entry here. I'm gonna cheat it just a little bit this way, give them a little bit of the benefit of the doubt, and come over here to the peak braking. Almost 1 second, right? 0.96.
Wow,
So
big difference.
Significant amount of time difference between when the driver got on the brake pedal to which he achieved peak braking. And this is going to pay a negative dividend to you the faster you're going. So when I'm looking at this time delta, I always want to look at the fastest braking zone on the track first and kind of work my way back from there, because the fastest braking zone is the one where it will make the biggest difference in terms of getting this right. Because you're traveling at a much faster speed, so that half-second delay means you've broken that much more early, right? So it's the faster you're going, the bigger this makes a difference. And I want to make sure that you guys understand that just because 0.5 is a target doesn't mean that's possible for everybody, right? In this particular case, we're talking about Spec E30 cars. They're kind of on the more softly sprung side of things. If you just jam that brake pedal as hard as you can, as fast as you can, you will shock the chassis and it may go instantly into ABS, right? That's not the type of mode that you want. You have to have enough of a progression in applying that brake pedal that you don't shock the chassis. The stiffer your springs are, the quicker your load transfer time is going to be. You don't have to wait for those front springs to compress and the tire to make full bite. But it's also possible on a stiffer chassis to quickly shock the actual tire and contact patch. So whereas on the Spec E30, we're waiting for the car to transition the chassis, on a more stiffly sprung car, you have to be concerned about shocking the contact patch and causing slip at the contact patch of the tire. So there's not a one-size-fits-all answer for everybody. And also, if you have aero in your car, that's going to also change, because that's going to change the normal force at the tire, which is what friction acts on. So the more weight on your tire for a given level of friction, that allows you to slow down at a faster rate. So those are why things like the aero on the car can make a big difference in terms of the amount of braking that you can do, and you actually have to ease off on the braking on an aero car as you get deeper in, because the normal load on the tire is reduced as your speed is reducing.
Perfect.
Hopefully that helps you make sense of why you won't always see the same number. But again, you want to understand what the limit is for your car and try to always be working towards that to get that quick brake pedal application and then ease off so you can trail brake into the corner and use all of the friction circle, all of the grip available with the tire combination that you have on your car.
Yeah, there is no table that you can just go to and say that this car does that. That's what this data is so powerful about, is you go out on track, and you can come in and take a look at it, and you can continue and improve different areas, and pretty soon you do find the max for your car combination, tire, track conditions, and those kind of things. So it's kind of fun.
And remember when we talked in previous webinars, right, the track profile, elevation, camber, those things, that affects these numbers as well, right? As does the track temperature, the ambient weather, the age of your tires, right? Those are all variables that go into this. So it's not just looking at one number that you have to look at, but certainly within a given session here, we should be able to see some comparison between when you're doing it well and when you're not doing it well, and try and move that brake marker back to the point at which you're not getting a dip where you're having to ease off the brakes before you're ready to turn in because you're not quite to your turning point yet.
Very good. Very good stuff. Very good stuff. You have anything else you're going to show us in some live data?
What's that?
You have any? You had another thing you wanted to show us?
Yeah, I was going to show an example here, since that turn one example wasn't so great for comparing, for showing the transition. Here's a little bit better transition of going from braking to turning, right? There's still a little bit of a dip, but not nearly as much as what we saw in turn one. So it is something that's possible to do. Also, when we were scanning through those laps, we can pick a given corner like we were before with turn one. And as we scan through the laps, we can see there's a difference, right? Here's a good one, right? Yeah. Where the braking G is held. But the one thing I don't like here, though, is my peak for braking isn't early. It's kind of in the middle, right? The curve looks a little bit better in terms of what we're using for the friction circle, the transition from braking to turning, but it's kind of late in the event. So probably there was still some compression here that could be done, even though we don't see a dip after the peak braking point like we did here back on lap 4. Right? We don't have that same dip, but maybe this is telling us that our problem here is on this side of still not, the transition was good, but maybe we could have waited a little longer and built that braking G a little bit more quickly. And let's see, let's turn on, yeah, you can see that here in the brake aggression, right? The brake aggression is a little bit off the scale here, but the green is a much softer brake aggression than it is here in the red. So there's, you know, another way to look at it from a comparison standpoint and see that you can see that the brake aggression here was less, even though we're seeing a better transition off the brakes into turning. So you got to kind of get the two together, right? You can get part of it right some of the time, but what you want to do is take those good pieces and combine them together where we get the right braking point with the right transition into turning.
Perfect. I'm
That covers most of the things I wanted to mention.
I'm glad you found a good example too. That's always helpful to see a good one at the end.
Yeah.
Perfect.
So if you have any more questions on that, just let us know.
We've pretty much cleared out the question and answer dialog box, so that's pretty good. You did a great job. Exactly. If you have any additional questions as we kind of close this up, make sure you throw those up in there. I'm gonna go back and share the presentation materials. How long, maybe? Let's do that. There we go. David's asking that question about Jeremy. What would it look like in a downhill? Your peaks would just be a little bit less, right? Because the car just will not take it, right? So the downhills are just everything's going to be pulled out and compressed a little bit more, right?
Yeah, when you're going uphill, you're going to get more weight available on those front tires, and you're going to see a higher G number. If you're going downhill, all of your peak numbers are going to decrease in their G level.
And that same basic thought process holds if you got a car with a lot of aero, right? So you'll see a little bit more when at higher speeds, kind of like you're going uphill.
Yep. Aero is difficult to show examples of because everybody's is so different when you start getting into aero. But what that allows you to do is to have more grip available at the tire for the same tire than you would without it, because you're applying more normal load at the tire. So friction, which is the actual mechanism that gives you the contact between the tire and the pavement, has a function component of weight. So if your tire only has 50 pounds on it, it can't stop very much. If your tire has 200 pounds on it, it can stop more than that 50-pound tire can, simply because of the weight pushing against the pavement and getting that friction to actually take effect. Physics
rule at some point, right?
Yeah, that's right.
From his engineering standpoint, physics rule. That's what he would have to say. Is brake speed something that AIM software provides? Go back and watch the video when we finish playing this. It's a math channel that Jeremy has provided, and you can see some of the different things in the video early. So perfect. While if you see something else you want to add, I'm going to start up another poll as we kind of wrap up with our training and support stuff. The training and support, it's really the added value of what we're trying to do here is making, these webinars are certainly a piece of that, but we have a whole bunch of other videos out there on our YouTube e-training site. I think we're above 70, 75, something like that. The number of videos we have out there are powerful. You can grab them, view them. They were designed, a lot of them are designed more of a short form than the webinar, but boy, if you want to see something about GPS lap insert, we're expecting it. Hey, it's there while you're at the track. Open it up, get the information you need, and close the video down. There's not a ton of production in a lot of these. They're just meant there to help you. So visit the site, kind of click around a little bit, not just the webinars, and you'll see a whole bunch of other videos as well. We're customer support.
How to write map formulas.
Exactly. We're a customer support company that happens to sell electronics, right? So we are just burning to get out there to be at the track and see all of our friends and help all of our customers. So if until we can get out at the track and start to see you, hopefully that's happening soon for us and everybody that all of you that are listening. If you still have questions and certainly emails, we're going to give you Jeremy my emails here in just a moment, but we have the 800 number, our tech line. If you have any questions about some of the stuff that we've done here or other hardware questions or software questions, give us a holler at 800-718-9090. We're here to help you. I'm going to start another poll here as we kind of start talking about what our next webinar will be. The next one is future webinar topics. I'm gonna launch that poll. It's going to be in front of your slide. This one will give you multiple. You can select multiples, but I would really like you to kind of pick your top 3 of the webinar topics that you'd like to see. We have been watching these. I'm gonna share this with you as soon as we get done here. But pick your top 3, and we'll chat a little bit about how this is really affecting what our future webinars are and training materials we're doing even outside of the webinars. So, we got about 50% of you voted so far. While you're doing that, I'm gonna chat about our next webinar. Our next webinar is to tie some of this even together even more. We're gonna on next Tuesday, May 5th. We're gonna have a host. It'll be his first time hosting. It's James Colburn. JamesColburn.com. What he's going to talk about is finding trends in your driving. So what we're going to take is take some data, obviously, and bring it up and go through some steps that you can follow fairly easily. Maybe you don't have data to share with somebody else. Maybe you're just looking at your own and maybe a session versus another session, or even inside of a single session, and finding trends. What are the things that you can work on? What are ways to look at your data and find trends in your driving that will help you understand what the next steps to go to? Pretty popular idea. James has been making YouTube videos and helping people in his motorsports career. So it'll be very fun to have him with us. I'm going to end the polling on that one and then share it with you, give you an idea of what people are asking for. The data analysis is still trying to get that added value out of your hardware. Is still continues to be a large piece of this. 83% of you, that was one of the 3 that you mentioned. The second one is track maps. The track maps has been consistently our second highest topic. So just a preview is James is going to do this on May 5th, and then on the 7th, the following Thursday, I'm gonna go ahead and present a track map in the AIM universe. What are track maps? How do you use them? How do they go throughout the different things that we do with them in our AIM universe? So that'll be on the 7th. There'll be an entire one covering that track map topic that has been pretty consistently the number 2, and it's in semi involved in the data analysis side as well. So I appreciate you guys doing that. Those are really helping us adjust our schedule to meet what's coming. So I do appreciate that. And finally at the end, just a little bit of more contact information. You've got my email address there. You've got Jeremy's. Jeremy, his website at FastTech has got some interesting information as well. So Jeremy, is there anything you'd like to add here as we kind of close up our webinar today?
No, just want to say thanks to AIM for the opportunity to come in and share with everyone. I really appreciate the AIM ecosystem that they've developed here, where it's very much a system of education. And if you don't know how to use your hardware, you're not going to get your benefit from it. So there's no better place to do that than with AIM hardware.
Thank you very much. I appreciate that. Thank you to all of our AIM techs that have been answering questions like crazy over there. I do appreciate that a ton, and look forward to seeing you in a next Tuesday with James, and we'll see you at the next webinar.
Thanks, everyone.
Thank you.